Review for Chapter 7. Chapter 7 is on probability. Probability is your chance. And without really taking this further, you didn't realize that Chapter 6 was really finding your chance if you randomly selected someone of landing in that position on your normal curve. So chance is success over total. So total, what we like to do in total, that's our sample space. Sample space is all possibilities. All the outcomes that I could possibly have. Complement, if you recall, the probability of an event A's complement is kind of like the opposite. So the complement and the probability of A are going to total 1. The addition rule, it's key. You need to realize that the addition rule is when you read the or. I want one or the other more likely than if I want one and the other. So when we multiply, we're going to use the and. So we'll do some examples to show you how all of those tie in. What is the probability of that will never occur? 0%. And 100%, or 1, is if it's going to always occur 100% of the time. Find the probability. If my event is 86%, then my complement would be 1 minus 86%. And you might want to think of that as 100, which would be 14% is your complement. The sample space of rolling a single die. When you're looking at sample space, it's a set. It's the set of all possible outcomes on that single die. And so those are numbers 1 through 6. What is the probability of getting a 6? Well, if you go back and look at probability, it was success. Whether it meant that you were going to win or lose, that doesn't matter. It's, I wanted a 6. So if I look here in this list, there is one value of 6 out of all 6 different numbers that I could possibly get. What's the probability of drawing a king or a queen from a standard deck of cards? So if I want a king or a queen, if I think about the number of kings, there are 4 kings in the deck, and there are 4 queens in the deck. So those are a total of 8 out of 52 cards that are either a king or a queen. Now, what is the probability of drawing both a king and a queen? So what I want to have happen here, I'm not really keen on the wording of this problem. I want 2 cards. And what's the probability that I get a king in the first card and a queen in the second if my cards are replaced? Replacement is key because it means that they are independent of each other. They would be dependent if I hung on to the king because the queen would come out of fewer cards. So if I wanted a king, we know there are 4 in the deck, and then I wanted the next card to be a queen. So you got to be careful of this because if I don't replace, then the first card, the king, is fine, but the queen then is 4 out of 51 because there are fewer cards in the deck. Now what we need to worry about here is not only the idea of replacement and not replacement, whether they're independent or dependent, but whether they're mutually exclusive or not. So to be mutually exclusive, if you recall, there's no overlap. So if I'm looking for probability of getting an ace and the probability of getting a diamond, there are 13 diamonds in the deck, but the problem is I want an ace or a diamond, but the problem is the ace of diamonds is counted in the first group and the ace of diamonds is counted in the second group, so I can't do that. So if I total up my cards, because I've counted it twice, I'm going to take it off. There really aren't 17, there are 16 cards that would be a success out of my total sample space, which would be all 52 cards. So in probability, it's chance. You need to remember how to calculate a sample space. So if you have children, if you recall, and you're going to have 2 kids, you could have boy, girl, and that combo is different than a girl and a boy. And of course, you'd have 2 boys and 2 girls. So you need to make sure that you realize that boy, girl, and girl, boy are different. Another way to think about doing sample space, if it's what we call a binomial, binomial means 2. So you've got outcomes, if you check here. If I have 3 outcomes, in my first position there are 2 possible second position 2 possible, third, that means I'm going to have 8 total outcomes that I might get. So what I like to do is kind of draw these lines on finding the total. Finding the sample space, however, is listing them all out. So the probability is going to be used in combination with Chapter 6 to make decisions. If my probability is small, such as 1%, that's not very likely. If my probability is 60%, that's likely. So someplace in here, in this whole decision making, we're going to start looking at these probabilities. We know this is unlikely, and we're pretty sure that this is likely. 60%, pretty likely to happen. But what about 10%? Is 10% likely? It might be to some, and it might not be to others. So what we're going to have to do here is use this idea of probability to make decisions, but we all want to make the same decision. We're all going to have to be willing to take the same chance. So that's going to lead us into Chapter 1, Part 2.